this is Naz from NV Network Lessons. I'm back. I'm going to solve some more examples of derivatives in this session. This is calculus lesson number 9. So let's look at some more examples. In my last lecture, I solved a function of x, which was 1 minus x squared, and then I drew the graph also, and then I showed you by drawing a tangent and showing you the slope. So I kind of showed you the theory part, how we get the derivative, and then I showed you by visualization on a plotted graph. So let's look at some more. Let's say we have a function of x is equal to 1 over 2x, okay? How would you solve that? If I asked you to find f of prime of this, how would you do it? Well, before you find the prime, I would like to see if I can simplify this equation. So I can write this like f of x is equal to 1 over 2 and bring this x into numerator. When I do that, it becomes minus 1, okay? So then we can basically say find the derivative of x. When I do that, okay, 1 over 2, it's a constant, so I can keep that over here. Then inside, I have x raised to the minus 1. And I apply the rule, which I showed you last time, which was, if you recall, x raised to power n, and if you do f prime of x, it's n times x n minus 1. So I'm going to apply this rule over here. I'm going to pull minus 1 right here, times x minus 1 minus 1, because minus 1 is already there, and then by rule I have to subtract it again. So when I do that, I get 1/2 minus 1 x minus 1 becomes minus 2, all right? So if you simplify this further, f of prime of x will be equal to 1 over negative 1 over 2 times x minus 2. Now you can either leave this like this, that would be a good answer, but if you want to show your professor a little more courtesy, you can do like f prime of x is equal to minus 1 over 2, and then bring this x minus 2 right here, and it will become positive. So that, my friends, is the answer. Now I would like for you to see if you can plot this, right? And then find the slope using this. It would be fun. All right, let's look at another example. So let's say we have function of x is equal to x raised to the power 3 over 4. How would you do that? Find f prime of that. Well, you've got the rule right here. Bring 3 over 4 as a coefficient times x 3 over 4 minus 1. All right? So if you simplify this further, you get x is equal to 3 over 4 times x. If you subtract 3/4 from minus 1, what will you get? Well, you can do some algebra on the side. You can say 3 over 4 minus 1 over 1. You take the lowest common denominator, LCM, 4. Then you get 3 minus 4. So essentially you will get minus 1 over 4. Okay, so then I can write x raised to the power minus 1 over 4. All right. Now this is good enough answer, but if you want to simplify it further, you can do 3 over 4 times x 1 over 4. Just bring this to denominator. When you do that, the sign changes. All right, so let's look at another example. What if I have something like this? Function of x is equal to 3x squared minus 4x plus 2. How would you solve that? Okay, so then I can do like d of f over d of x is equal to 2 times 3, 6, x, 2 minus 1, minus 4, x times 1 minus 1. Essentially, I'm applying this rule. And then this is a constant, so derivative is 0. Now you notice that instead of f prime, I wrote df over dx. It's the same thing. Okay, so f of prime of x is df over dx. It's the same thing. I just wanted to show you that. So then you solve this further and you get 6x minus 4x raised to the power 0. Now you know anything raised to the power 0 is 1. So then we get 6x minus 4. That is, my friends, the derivative or slope. This is the slope of this function right here. This function right here. Okay. So if you have a calculator, you know, and you can plot the graphs, you can go ahead and plug in this equation. It'll show you a graph. Okay. And then if you want to find slope at any given position, you can just change the x and it'll give you the slope. So thank you so much for watching. I just wanted to solve these examples. I'll come back and solve some more examples for you and solidify the derivative concept in your mind. And then after we are done with derivatives, we're going to move into integrals because we need them to analyze AC circuits, especially the integrals. Thank you so much for watching. Have a good day. See you next time.